Hi everyone, and welcome to the Survey Codebook lecture. Let's get started. So survey codebooks are documents that provide the reader with a way to essentially read the survey answers without ever having to see the questionnaire itself. Before we create a codebook though, we have to quantify our survey. Survey quantification is the process of converting data, no matter what form it is in, into a numerical format. So our original data could be pictures, words, phrases, categories, whatever. But in order to help us analyze them statistically, we're going to quantify this data by creating a numerical system for it. Quantification helps researchers create electronic databases. If you're familiar with Excel, you know the challenges of putting a long block of text into Excel and then scrolling through your worksheet to compare columns and rows. By quantifying the data, we can get long blocks of text into simple numerical values that we can easily compare across the entire spreadsheet. Quantification also helps us analyze and visualize our findings because we can do a lot with numerical responses that we can't do with text-based answers. The process of quantification is also called coding, and you'll hear me use both terms during this course. The first step of quantifying survey questions is to create a coding scheme. The process of creating a coding scheme is impacted by the question's level of measurement. I told you that concept was going to be important later, didn't I? I recommend pulling out that flowchart we did previously to help you figure out level of measurement as we go along. As a quick reminder, nominal variables are categories that cannot be put in order, and ordinal variables are categories that can be put in order. Since both of these are categories, we're going to have to create a unique numerical code for each category. Interval and ratio are both numerical values themselves, with interval attributes able to go negative and ratio options having true zero. Since both of these are numeric in value, we can use the number itself as our coding scheme. Let's do some examples together to help illustrate this process. Let's start with a nominal variable. The example variable is political affiliation, and respondents are given the option to choose either Democrat, Republican, or Independent. These categories are non-numerical and they can't be put in order from least to greatest, so they're nominal level. Now we're going to assign each category a unique numerical value. I'm going to use 1, 2, and 3. Now these values don't mean anything. In fact, we call them placeholders. They are just something we use to keep track of which category the respondent identifies themselves as fitting into. I could have used any number I wanted to, 85, 64, 72, whatever. But typically a 1, 2, 3 type of system is one of the easier to understand during analysis. The numerical values we've added here are called our coding scheme. They are the values that we use to quantify the survey responses. Now there's one more thing I need to consider in my coding scheme. Often survey respondents will skip a question for some reason. Maybe they didn't see the questions, like they were on the back side of the paper, or they didn't feel comfortable answering, or they didn't understand the question. Sometimes they will purposely answer the question wrong, like selecting multiple options or putting outrageous values, like they have 982 children or something. We call all of these issues missing data. For whatever reason, the question hasn't been answered for the research purpose, and we want to document that. So when we create a coding scheme, we want to add in one last category for every question, missing. Missing data will get its own numeric value. You can just give the missing category a value of 4 for this variable. The problem is that if the next variable has 5 categories and then also a missing category, then the missing category would be 6 on the next variable. That makes it kind of confusing to code. So oftentimes we use a value that's really far outside of possible values, like 99. Other times we use a period to indicate a missing value. It all depends on the software that you're using. Missing data is purposefully excluded from any data analysis, so it doesn't matter what value you end up using. In this course, I typically will use Excel for help, and so we're going to use a period. Excel will not include a period in any numerical analysis, so it's a good option for us to use to represent missing data. So when we're coding, we're going to use a period to represent any survey that skips the political affiliation question or whose responses are unclear for some reason. Not too bad, right? Ordinal variables are similar, but because they have a rank order, we want to make sure that we put the attributes in order before assigning the coding scheme. The order can go from lowest to highest or highest to lowest, whichever way you prefer, so long as it is appropriately ranked. Let's take a look at this example of education level. The respondent is given options ranging from high school degree to postgraduate schooling. I've put them in order from lowest education to highest education, and then created a numerical coding scheme just like we did before. And like before, I've added a missing option using a period value. Like I mentioned, the order of my numerical codes does not matter. Remember that these numbers are just placeholders, so the value themselves is of no concern to the researcher. Sometimes we prefer to structure our coding system from greatest to least, which would look like this. You could choose whichever one you want. The coding system for each individual question should be considered carefully, even if the questions have the same responses. For example, look at this sample Likert scale survey. There are 3 questions. I would like to use this system frequently. I found the system unnecessarily complex, and I thought the system was easy to use. For each question, respondents are given 5 choices, ranging from strongly agree to strongly disagree. Here's the concern. Look at question 2 compared to the others. If I strongly agree with questions 1 and 3, it means I'm satisfied with the system. But if I strongly agree with question 2, then I don't like the system. So if I use a consistent coding scheme for all 3 questions, I'll end up having a confusing situation where a high score sometimes means dissatisfied and sometimes means satisfied. In this case is known as reverse coding. I will reverse the order values for the negative question so that a higher score equals more satisfaction, no matter what the actual questions themselves say. So statements 1 and 3 will both be scored from 1 to 5, with 5 indicating the respondent strongly disagreed with being satisfied, and 1 being the respondent strongly agreed with being satisfied. Statement 2 will then reverse that coding process and score strongly disagree as a 5, because that means they were satisfied, and strongly agree as a 1, because that means they weren't satisfied. Now the survey is set up so we can add up the numeric value of all 3 statements and determine how satisfied the respondent was. The final score would range from 3, which would be all 1s, to 15, which would be all 5s, and the higher value indicates higher satisfaction with the system. This is a really common process for Likert scale questions, and it can be helpful for reliability purposes to purposely put reversed variables into a scale so that subjects can't just run down the line and click strongly agree with every statement without carefully considering their answer. Now let's turn our attention to interval and ratio level variables. These are a little different because the respondent has already provided a value to the question, so we don't need to create a placeholder. In this example, respondents were asked to select their specific age with options of 20 years old, 21 years old, 22, and 23 years old. All we have to do is remove the units years old, and we have our coding values. 20, 21, 22, and 23. We also can't forget to add in the missing values so that if our respondent skips the question, we still have a way to code their answer. And now we've completed our coding system. Easy, right? Up until now, we've focused solely on quantifying closed-ended survey questions. Open-ended survey quantification is a little more complicated, but still not too bad. What we will need to do with open-ended questions is first create categories to represent the different responses, keeping in mind the exhaustiveness and mutually exclusive requirements that we've discussed before. Once we get our responses into separate categories, then we can code them just like we talked about as categorical variables. So the first step with open-ended survey questions is to read through them carefully and organize them into separate groups based on what you're reading. Then assign each of these groups a category name and code as normal. For example, in this image, the respondents were asked to describe one thing that they would change about internal communication if they were able. They were allowed to write whatever they wanted. The researcher analyzed the text of each response and created 4 categories: email overload, be transparent, improve timelines, and simplify messages. They can then assign each of these categories a numerical value and code each response appropriately. If you're interested in seeing this process more fully, I've provided a link here to a short YouTube video that will show you how to categorize open-ended responses and then analyze them statistically in Excel. And I said here, I meant I have it on my website. One last coding situation I want to discuss is the check all that apply question. These are a bit of a doozy because they can't be handled like a normal question. Let's take a look at this example. You're asked to describe who resides in your household on a permanent basis, and you're allowed to check all that apply. There are 6 options for the respondent. parent, child, roommate, sibling, extended family, or live by myself. If a respondent checks I live by myself, they would not check any of the other options. But none of the other options are as exclusive. Maybe you live with your parents and your child, or a sibling and a parent, or a child and an extended family member, or 3 different categories. When you're coding a question like this, you have 2 options. First, you can create a unique code for each combination of responses. That means you have to have a separate code for parents by themselves, parents with child, parent and child and sibling, and so on. As you can imagine, this coding scheme would easily get into the hundreds with more complicated questions. Instead, the more common approach is to code each answer choice separately. That way, you can easily document which options were checked and which were not checked without requiring 8,000 combinations. So what does that look like? It means that each option will have its own coding scheme. The good news is that the coding scheme is super simple and repeats for all the answer choices. I start with the first option, living with a parent. I create a simple yes-no coding scheme where the variable is coded as 0 if the respondent does not check this option, and 1 if the respondent does check it. I also include a missing category using the period, just like I've been doing previously. Then I go on to assign the same coding system to the remaining 6 options. So this one question actually requires 6 separate coding schemes and 6 separate codes in order to fully analyze it. One thing that is important to recognize is that even though these coding schemes are separate, the missing option is treated like a group level variable. What I mean by that is that the only reason you would check missing if the respondent has skipped the entire question, has checked none of the options, or if the options were somehow problematic. For instance, if my respondent checked I live alone, but then also said I live with a parent, I would classify that as missing because something's wrong with their answers. So it's just important to realize that missing data decisions don't look at each individual option, but rather the entire question. If you do need to code the responses missing, then you're going to code all of the options for that respondent as missing. So that would be 6 period options to indicate that the person skipped the question. Once you have successfully quantified a survey question, you will create a code book documenting the code. The goal of a code book is to help you understand a data set of quantified values, essentially allowing you to uncode the data and uncover the meaning behind the analysis. Codebooks are also helpful for reviewing survey data because you can find which variables you want to analyze for your research question and what their coding schemes are. Codebooks have no absolute required format, but there are some standard pieces of information that you will find in most codebooks. Typically, codebooks include the following: the variable name, the question text, all the possible responses for the variable with a unique code value and values for the missing data. The variable name is a short descriptive name, typically without any spaces, that allows readers to identify the correct variable easily. Variable names are the column titles in most statistical software programs and in Excel, so the emphasis on short names is because the columns are not always very wide and longer names will get cut off. Here's an example of a codebook entry. The question that the respondent answered was, how often do you attend religious services? That is the question text. The short variable name given to this question was attend. This would fit easily at the top of a column and lets the reader understand what the variable is about. The options provided to the respondent are listed here, ranging from never to several times a week. Each option is given a unique numerical code starting at 0 and ending at 9. And number 9 indicates a response of don't know or no answer, which is our missing data option. So if someone skips the question or they didn't answer it or they answered it wrong, sometimes they answer 2 or 3 numbers and you can't tell what they're actually trying to answer, you would put a number 9. Here's that same example along with another ordinal example. Again, question text, short variable name, variable attributes with unique coded values, and a missing category option. All right, well, that concludes our discussion about creating codebooks. Thanks for watching.